So hydraulics. This is one of our bigger sections that we're going to look at. The hydraulic systems are incredibly important on transport aircraft. They are what make pretty much everything work. And so there's there's a lot that we're going to cover in here. And so we'll kind of spread it over, we'll take a break and that kind of thing partway through. But the hydraulic systems are covered in ATA 29. And now that is just for when you're going to look for information and that kind of thing. ATA 29 covers the hydraulic systems themselves. However, there are a lot of there are items, the hydraulics are powering on the aircraft that will have a hydraulic component in them. So what I mean by that is, when we look at landing gear, it's going to have hydraulic brakes and it's going to have hydraulic for retraction, that kind of thing. The brakes, even though they are hydraulic, they're covered, with landing gear. With flight controls, you have hydraulic actuators that drive flight controls. Those are all going to be covered. The actual actuators themselves typically are covered in Chapter 27, flight controls, not under the hydraulics. So you got to find that break point sometimes. And when you're working on one of those edge cases, say a hydraulic actuator for a flight control or for a door or for a landing gear, sometimes you do have to check both manual sections. Is it in the hydraulics manual section or is it in the manual section for whatever it is that's using the hydraulics? So, and different manufacturers sometimes break it up slightly differently. So it can make it a little bit more difficult to find some of those edge case areas. For this, we're mainly going to look at the hydraulic system function, the main, the portions of it, not the actual what we call user systems, or not the user devices. We'll talk about them briefly, but then we'll talk about them in more detail with the individual areas or systems that those tie into on the aircraft. So to get started, look at this. So I mentioned that hydraulics are important. They're the lifeblood of the aircraft. Just a list of items that are going to be affected or going to be interconnected with hydraulics. If you remember back to the first lecture I did, part of the study we're looking at is interconnected systems and how hydraulics affect the other parts of the aircraft. So, on most transport category aircraft, the primary flight controls are going to be hydraulically driven, as are most of the secondary flight controls. Landing gear for extension and retraction, and kind of part of that is the braking system as well, runs off the hydraulic systems. It's not separate or independent. It's part of it's driven directly by the hydraulics. Ground steering, steerable nose wheels, things like thrust reversers on some aircraft, and then kind of on some, not necessarily all aircraft, but hydraulics can run things like generators. We can have hydraulically operated doors, stairs. You can also, there's other uses that are out there beyond just this list. So, but before we get too far into it, we want to know what exactly hydraulics are. So if you look at the formal definition, it's the science dealing with the laws governing water or other liquids, in our case, hydraulic fluid, and their application for engineering, practical, or applied hydrodynamics. So to put it simply, for our use, hydraulics are using liquids to do work and using hydraulic fluid to do work. And the simple breakdown, if you look, this bottom line here, what is a hydraulic system at its highest level? Most simply, you have to have some kind of a pressure source, and then something that's making the pressure, and we're going to be converting some other kind of energy into pressure, and then that pressure is going to be conveyed, and we have to control the pressure, and ultimately it's going to make something move, actuate, or activate. And so when looking at them, I talk about the pressure source. Pressure sources can be any number of items, but we got to take some kind of an energy source and convert it from electrical or mechanical or whatnot to hydraulic pressure. And so we can take, looking at the various places the pumps are, If we have an engine-driven pump, we're taking energy stored in the form of fuel. We're burning it into an engine that's creating thermal and then rotational or mechanical energy. And that mechanical energy is turning a hydraulic pump to create pressure. From the electrical side, you have an electric motor driving a hydraulic pump. That electric motor's got to get its power from somewhere. And so, we have that. And then there can even be things like the air running past the fuselage in an emergency we can use as an energy source to drive that pressure source. So for large aircraft systems, we're going to be looking at systems that have a constant pressure and variable flow, which is different than what you would have studied for small aircraft. Small aircraft have a variable pressure. The pressure is cycled on and off, or it's turned on only when it's used. With large aircraft, the system is always trying to maintain a steady pressure anytime that the systems are running, which is basically from power up to shutdown. And most aircraft today are maintaining 3,000 psi, although some of your newer aircraft have pressures upwards of 5,000 psi or more in the hydraulic systems. So, and those higher pressures, we can use a smaller component to get the same amount of force or power out of it. But 3,000 psi has kind of been industry standard for a long time. And so that's what our pump's trying to maintain. Now, there are times where that pressure may not be maintained in what are known as high demand situations. So if you're running a lot of equipment, a few of you have seen us running some hydraulically activated equipment on the 727, and noticed that as we started to move like a bunch of flight controls and other things, that the pressure in the system dropped because our pumps couldn't keep up, because we're only running 2 of the 4 pumps on the ground. And so, normally it's trying to maintain 3,000. It'll drop if it can't maintain that flow. But once it catches up with demand, it's going to return to that 3,000 psi. And when we're not really activating much of anything, it should stay at 3,000 psi most of the time. The flow is varied to match the system demand as much as possible up into the max capacity of the pump. And these are known as closed center hydraulic systems. We'll do a quick comparison to open center that are on small aircraft. So large aircraft, nowadays, almost every transport aircraft out there is going to have 3 or possibly even 4 hydraulic systems. These are just some diagrams, and we'll look at these in more detail here, but these show the 3 hydraulic systems that are installed in an aircraft, where they're located and where they're powering. If we look at them in a pictorial view, so here's the pictorial view. If we look at them from a schematic standpoint, this is the same aircraft with the same systems, showing the three hydraulic systems, hydraulic system 1, 2, 1 on the left, 2 on the right, and they put 3 in the middle right here, as well as what the different users are. The one thing this doesn't show is the return path. So this shows the reservoir, the pressure source, going out to the various items. The assumption is that from your various users, which are all the rectangles kind of across the middle, then fluid returns back to the reservoir after activating the various devices. So you can see here all the different things that are, including, starting on the left, including things like thrust reversers, spoilers, elevators, brakes, rudders, ailerons, and then on the other side, right hand and brake, kind of a lot of the same items. Some aircraft may add door activation to that and other devices as well. So we kind of compare them side by side. Here's that number 1 system that we saw pictured in the aircraft, and we can kind of trace a couple of the items to where they stand on the schematic. So right here on the left engine, that's number 1 system. It shows a left engine-driven pump, which is right here. And then it has a AC motor pump, and that's shown in the picture here. So here's our AC motor pump. And then the lines going out to the various areas. So it talks about the multifunction spoilers, left and right multifunction spoilers. No. Those are these ones, some of the ones shown on this The multifunction spoilers and the ground spoilers are shown here on the wing,
when I actually combine it.
as well as the upper rudder and the left-hand elevator. Okay, so these are all your users that I circled later that are shown down here. Okay. If you look at that same aircraft, the number 2 system looks very similar. You again have and this is a pretty common setup where you have an engine-driven pump as well as an AC pump. And then it shows all the various users on the aircraft, including in this case, it includes now the right-hand thrust reverser, spoilers on both wings. This one includes aileron control as well as elevator, and both elevators now and the rudder. And then if we continue on to the number 3 system, you can see here the number 3 system has 2 AC motor pumps that are physically located back in the tail rather than in the middle. So we've distributed our pumps. There's 6 pumps driving 3 systems, and 2 of them are on the engines. 2 of them live kind of in the middle of the airplane. Remember on the earlier slides, the AC pumps were here. And then for this system, the AC pumps are back in the tail. So if we were to have a part of the aircraft damaged, ideally it's not gonna hurt all the pumps. Just something not shown here, but those pumps are gonna run, they're gonna be primarily wired to different electrical buses. So if we go kind of back a little bit, let me go back 2 slides here. If we go back here, this is our engine-driven pump here. More than likely, this AC pump right here is actually driven off the number 2. It gets its electricity from the number 2 electrical bus, which is primarily run by the right-hand engine generator. So you can see both engines, in a way, one directly and one indirectly, have a way to power the number 1 system. And then the number 2 system kind of would be the same thing. In this case, the number 2 mechanically driven pump is driven off the right engine, and the number 2 electric pump would get its electricity from the left engine generator. So you kind of have a way for both engines to run the number 2. And then on the number 3 system, it's got 2 electrically driven pumps. One of those pumps is primarily going to get power from the left engine. One of those pumps is primarily going to get power from the right engine. But again, any of them, we can connect the buses, as we talked about in electrical, to power all of them off of a single engine or even the APU potentially. And so there's a lot of where you can see backup and redundancy in these because they're such critical systems. The other thing I want to point out is most of your flight controls. Here you can see the ailerons can be controlled by the primary flight controls. The ailerons get power from the number 3 system. The ailerons also get power from the number 2 system. The left elevator gets power from the number 1 and the number 2 system. The right elevator gets power from the number 2 and the number 3 system. Here it shows the rudder getting power from the number 3 system and from the number 1 system. So, again, any single hydraulic system is able to allow the aircraft to maintain control, through those various redundancies and kind of overlaps in what they do. The other thing you'll see is like different flaps, here, ground spoilers and flight spoilers. Some of them are on the number 1 system, some of them are on the number 2 system. Okay. Brakes, the number 1 system does your outboard brakes on this aircraft, and for instance, there's 2 wheels on each main gear. So the number 1 system does the outboard brakes. The number 2 system does the inboard brakes. And so you have braking no matter, as long as you have one of those 2 systems. If you only have the number 3 system, you just try to find a longer runway. So, but you probably still, at that point you're gliding and just trying to get the airplane on the ground somewhere if you're down to minimal systems. Okay. So if we look at those systems a little bit more in depth, I mentioned earlier, you're gonna have an energy source, whether it's the electric motor, engine accessory gearbox, a wind turbine, or even a manual pump, like our 727, the emergency gear extension, as well as that retraction of the air stairs. You have the ability to manually pump it. Those different energy sources are gonna power a pump, and then the pump's going to get fluid from a reservoir to send out through conveyance lines, and then goes to our various users. And along the way, it may encounter things known as accumulators. You'll have heat exchangers to cool the fluid, different control valves, which operate actuators and motors. And then as the fluid either goes out or comes back from the system, you're going to have various filters in order to keep the fluid clean. So with that, I'll kind of call that the introduction. We'll go ahead and stop, and it's 10:50. So let's